Welcome again to the continuation of the topic integration. We want to see how to solve this question we have for us. Now, they say integrate this, the x. When you see this type of question, apply partial fraction method. How do you do it? You can see that in the denominator that x squared plus 1 cannot be factorized. So you now say to integrate x minus 1 all over x squared plus 1 bracket x plus 1, that it is equals to ax plus b all over x squared plus 1. Why are we packaging it this way? It's because the denominator is not factorizable. This is a quadratic statement, but we cannot factorize it. So we now say ax plus b, then plus another alphabet c all over x plus 1. We say this is equal to, look for LCM, we have x squared plus 1 bracket x plus 1. This divide this, you have x plus 1. X plus 1 times this, you have ax plus b bracket x plus 1 plus this divide this, you have this divide this, you have this times this, you have c bracket x squared plus 1. Now this denominator x squared x plus 1 equate it to 0, that will be giving you that x equal to minus 1. Take it and plug in here. You know that everything here means x minus 1 all over x squared plus 1 bracket x plus 1. So what you do is carry minus 1 put in here, carry minus 1 put in here. Okay, what do we have? We now say minus 1 plus 1, 0, 0 times is 0. Minus 1 plus this. So for here, minus 1 plus 1, 0, 0 times is 0. We now say c bracket minus 1 squared, 1 plus 1, 2, equals to, equate it to the numerator, minus 1 minus 1 minus 2. Okay? Therefore, c equal to minus 2 over 2 equal to minus 1. That is telling us that why we do it this way, because this denominator equal to this denominator. So as you say x plus 1 equal to 0, x equal to minus 1, carry minus 1, plug in at the numerator. So if you plug in here 0, if you plug it here minus 1 square, 1 plus 1, 2, 2c equal to minus 1 minus 2, so c equal to minus 1. So what you now do is, since you have gotten your c, you now say what is your a and what is your b. You say, let me expand everything. If I should expand, I'll be having ax times ax times x, ax squared, ax times 1 plus ax, b times this plus bx, b times this plus b, plus c times this cx squared, c times this plus c, I will say is equal to x minus 1. I'm comparing the numerators. So if I'm comparing the numerators, what I will have is that I will say collect like terms, ax squared plus these two have x bracket a plus b. We have ax squared, we have cs squared. So we now say when we factorize, we have x squared bracket a plus c. This will have x plus s bracket a plus b. Then this does not have any alphabet x plus b plus c. We say is equal to s minus 1. Then comparing their coefficients, we have, here I have x, here I have x squared. Do we have x squared this side? No. We say a plus c equal to 0. Because here x squared, no x squared here. It means that a plus c will be 0. Then here a plus b, it has x. What do we have here? Do we have x here? What is the coefficient? 1. So it means that a plus b equal to 1. This one does not have alphabet. We now say b plus c equal to minus 1. Here we say since c is equal to minus 1, a will be equal to minus c, and that will be minus bracket minus 1. That implies that a equal to 1. Then if a is 1, what will be your b? We now say your b equal to minus a, your b equal to 1 minus a, your a 1, it implies that b equal to 1 minus 1, 0. So therefore, a equal to 1, b equal to 0, and c equal to minus 1. That is what we will use to plug in here. What is my a? My a is 1. I put it here, it will be giving me 1x. My b is 0 plus 0 all over s squared plus 1 plus, what is my c? Minus 1. Okay? I will now have minus 1 all over x plus 1. So integration of this simply means integrate this and integrate this. How do we integrate this? We say integration of x over x squared plus 1. How do we integrate it? Let your u equal to x squared plus 1. That means the u dx means differentiate this. Differentiate x squared, it will give you 2x. Differentiate 1, give you 0. So that implies that if you make the s subject of formula, it will be the s come up, the u all over 2x, because 2x will go down. So what you now do is that if you are to integrate this, you have to integrate the one after the other. So if you are to integrate this, you will be having integration of x all over u. Then what is the x? Times the u all over 2x. So this will cancel this. So continue, we have that the answer will now be integrate. Your answer will now be integrate the u, integrate 1 over u du. Now, since integration of 1 over x, the x is equal to ln x. Integration of 1 over u du will be giving us ln u. Okay? So, and what is our u? We say ln x squared plus 1. Then we come to the next one. Integrate 1 over x plus 1. For us to integrate 1 over x plus 1, we say integrate 1 over x plus 1 dx. That will also be giving us ln x plus 1. Since integration of 1 over x is ln x, so integration of 1 over x plus 1 will give you ln x plus 1. So the final integration will be integrate this over this minus integrate this over this. That will be giving us remember, we didn't bring out this 1 over 2. Here we have 1 over 2. 1 over 2. When you cancel x and x, 1 over 2 will fall out. Please don't forget that 1 over 2. So this will be giving you 1 over 2. While this one will be giving you x plus 1. Please, we got this 1 over 2 from here because we said x divided x 1. So we'll be having the u over 2u. So that the u over 2u, we should not throw that 1 over 2. We shouldn't throw it away. You write it. Okay. Integrate this lane u. And u is x squared plus 1. Then, packaging these two together, we say that finally, integration of x minus 1 all over x squared plus 1 bracket x plus 1 dx. That it will be giving us, what do we have here? 1 over 2 ln x squared plus 1. Then we have minus ln x plus 1. So this is the first answer to it. You can even continue by packaging your answer by saying this will be equal to ln x squared plus 1 all raised to power of, when this go up, 1 over 2, all raised to power of 1 over 2. Then you now say minus ln x plus 1. Then this will be giving you ln from logarithm bracket x squared plus 1 raised to power 1 over 2 raised to power 1 over 2 all over s plus 1. So that is from law of logarithm. So this is ln x squared plus 1 all raised to power 1 over 2. Division is from this minus s plus 1. You say plus c. So that is the final answer from integration of this. Please and please don't forget this du over 2. Don't forget this over 2 we have. While bringing it here, you now have 1 over 2 ln x squared plus 1. Then integrate this ln x plus 1. Then what you'll be having is now is when you package these two, now integrate this, it gave us 1 over 2 ln x squared plus 1. Integrate this to give us ln x plus 1. So we now start packaging them together. We now say this 1 over 2 will go up 1 over 2. Yes. Then minus this. That is from law of logarithm that we use to shift this to be at the power. Then what you now do is that law of logarithm subtraction law will also go in. This, take ln, write this all over this plus c. Then we go to the last question. The last question says integrate cos. How do we do that? You say to do it, integrate cos x sin x dx. Say let your u be equal to sin x, because when you differentiate this and invert, it will cancel this. The u ds will be giving me cos x. Therefore, make the x subject of formula, the x will come up, the u over cos x. Then what you now do is that you come and plug it here. You say this means integration of cos x root u. What is the x? The u over cos x. So this will cancel this. That will be giving you integration of root u. Then that your root u is the same thing as u raised to power 1 over 2 du. How do we integrate this? We now say, since the power is 1 over 2, Add 1 to the power. 1 over 2 plus 1. That will be giving us 3 over 2. All over the power 3 over 2 plus c. Then that tells us that what is your u? When this, in fact, it will be giving you 2 over 3 u raised to power 3 over 2 plus c. What is your u? Your u is equal to sine x. Sine, you say sine x bracket 3 over 2 plus c. So this is 2 over 3. Let's write it well. Equals to 2 over 3 sine x 3 over 2 plus c. Okay? So that is how to integrate this and this. That is how to integrate this and this. So that tells us that if you have to integrate this, just follow these procedures and get it. Thanks for watching today's video. Please don't forget to click like button if you enjoyed the video and subscribe. See you next time.